This lesson will provide a basic overview of where we're headed in this course. Specifically, we'll talk about the research process, statistical reasoning, and get into measures of central tendency, variability, and also a little bit about data visualization. So these first couple chapters in your book, chapters 1 through 3, really help set the tone for the course and get at this idea of why statistics is important and why we should be caring about this kind of information. So not surprisingly, we see examples of research every day. If you just open a newspaper or check the latest headlines on the internet, you see headlines something like this. These are some of the more amusing ones. I personally like the higher beer prices cut gonorrhea rates, texting improves language skills, children get better grades when families eat dinner together. So we see this kind of research reported constantly in the news. With the availability of information, it's really easy to get research out quickly to the general public. However, we have to be careful when we're interpreting this research to make sure that we're drawing appropriate conclusions and using this information in a good way. When we're talking about research, there's two main approaches we can talk about. The first is the deductive approach, or sometimes call this a top-down approach. The second is an inductive or bottom-up approach. So the deductive approach involves having a hypothesis, collecting data around that hypothesis, and then making a decision whether we accept or reject it. The inductive approach, on the other hand, first starts out with observations. From those observations that we're seeing in our environment, we're looking for patterns or some kind of interesting thing that we might be observing in nature, and from that, then we make a hypothesis. So both of these approaches are used in science, in different types of science, whether it's healthcare or education or social science. So we use both of these approaches. However, there's sometimes a problem with the second one, the inductive approach. So let's look at an example of that. Here we have a study that was published recently. This is from 2013 from Mother Jones. And you can see here on this line graph that they looked at the general population. They did a survey and they found this incredibly strong correlation. If you look at the lines, they're almost on top of each other. An extremely strong correlation between people who like sushi and people who approve of gay marriage. So it's one of those amusing things that you might read on the internet. And if you see here on the x-axis, we see that there's probably a third variable that's driving this effect. So people who are older maybe are less interested in trying sushi, especially if you're from Nebraska. Maybe we don't trust raw fish here. We don't know where they came from. They also might have more traditional values about marriage. Whereas millennials or Gen Xers down here, they might have more liberal attitudes and might be more open to different types of food like sushi. So in this case, there actually isn't a relationship between sushi and views on marriage, but both of those effects are being driven by a third variable of age in this case. The other classic example that I used when I took statistics a long time ago is that ice cream sales tend to be highly correlated with murder rates, which is a bit of a morbid example. But if you take a step back and think about what third variable might be playing a role, ice cream sales go up in the summertime when it's hot out, and similarly, crime rates go up in the summer when it's hot out. So really this variable of temperature or heat is actually driving the effect. There actually isn't a relationship between ice cream and murder. Otherwise, we would probably outlaw ice cream and we would all be really sad. So the moral of the story for both of these examples is that we have to be careful when we're just looking at patterns of data. Our statistics will only take us so far. We really have to think critically about how we interpret them, and specifically this idea of a third variable. Your book also calls it a spurious correlation, or you sometimes see it called an illusory correlation. So if we click back a couple in the slides here, I encourage you to think about what other variables might be causing the phenomenons that we're interested in here. So for example, the very last bullet, children get better grades when families eat dinner together. It's probably not so simple as just sitting down and eating dinner. You could imagine that families who eat dinner together maybe do other things together, like make their kids do homework. If the families are eating dinner together, presumably both parents are home, and they're able to sit down and have the time. So they're probably working, maybe have higher incomes, maybe can hire tutors for their kids. So you can imagine that it's not as simplistic as just eating dinner together and magically improving your kids' grades. There's probably multiple variables that are affecting this. One way around the problem of the third variable issue is to use the deductive approach to research. So this typically involves having more control over how our data are collected. So for example, on the previous slide with the headlines, one of them was whether or not Facebook is associated with bad grades in college. So rather using data that already exists, I could recruit people into my study and randomly assign them to groups. So one group might be allowed to use Facebook, the other group isn't allowed to use it for a length of time anyways. So this would give more control over the other variables in our study by using this random assignment to groups. So things like people's personality traits, their age, their general intelligence, their level of responsibility. These traits should even out if we're randomly assigning people to groups. So after that, I could then measure how much the students use Facebook and then see what happens to their grades. Now, once that data is analyzed, I'd be able to draw much stronger conclusions about the link between Facebook and grades than just looking at these naturally occurring patterns. We'll be focusing on two types of statistics, descriptive and inferential. Descriptive statistics do just that. They only describe information. A good way to think of descriptive statistics is that descriptive is past tense, so something that's happened before. So for example, I can say that in the past, the average score on an exam in statistics was a 75%. So we're really finding ways to organize, summarize, and communicate a group of observations that's happened. Inferential statistics, on the other hand, is when we're trying to predict what's going to happen in the future. So I could use information from prior classes that I've taught to predict how this class will do on an exam. So in this case, we're using data from a sample to make guesses about a larger population. So I can use data from the past to generate predictions about the present and even further down the road in future classes. So here we have, again, the definition with descriptive and inferential statistics. I wanted to point out, though, at the bottom, though, this idea, the word generalizability. So you can see on the right-hand column, generalizability to the population is not really the objective of descriptive statistics. So again, we're just describing the here and now, or perhaps something that's happened in the past. Whereas inferential statistics, we're interested in this idea of generalizability. So we would like to be able to extend or to generalize our results to other samples, populations, across people, time, places, etc. Which brings us to another important distinction, the difference between a sample and a population. So you can see here the population includes all possible observations about which we'd like to know something. That's a wonderfully vague definition, and that's really by design because a population can be anything. A population could be the students in this class. A population could be all students at College of St. Mary. It could be all college students. It could be all human beings on the planet. So the population is really dependent on how we define it. So you can see how it might vary quite a bit. A lot of times in research, we're interested in kind of that general population of humans. So if you think about healthcare, we would like our research findings to extend to all people, not just a specific subset. Same thing with education. We would like to impact all children or all adults, not just a specific subset of those. So the population includes everyone we'd like to know something about, whereas the sample, it's a subset of observations drawn from the population. So it could be that our population of interest is all college students, and we could take a sample out of College of St. Mary, or we could take a sample just out of this classroom. We'll talk about these two terms quite a bit throughout this class. We'll kind of start by saying that we often use samples in statistics just because it's hard to get entire populations of people to participate in our research. So things like the US Census, they try to contact every single person in the United States population and measure them, whether they're employed, what their education's like, their age, and so on and so forth. This is actually incredibly time-consuming. And it's a little bit impractical too, because we could actually get really good data about people in the United States by drawing a random sample of people. We could get pretty accurate rather than trying to single out every single person and talk to everyone. So here's an example of a population. If we were interested in the average salary of psychology majors who graduated from college in 2004, we would have to somehow track down every single person who graduated in that year with that degree, and we would ask them what their salary is, and we would take the average. And by generating that value, that average, we would call it a parameter since it comes from a population. Kind of the same idea here. If we were doing this with a sample, we might select people either randomly or non-randomly, people who graduated from 2004, and again, calculate the mean or the average and try to use that information to say something about the average salary of psychology majors. And in this case, that value, we would call it a statistic. So here we have a nice mnemonic device. So numbers or numbers that come from samples we call statistics. Numbers that come from population we call parameters. So the S's match up and the P's match up. I want to go through a couple other kind of basic vocabulary words just to make sure that we're all on the same page and using the same language. We'll be talking a lot about variables, and a variable is really anything with more than one value that we're interested in research. So this could be something like income, gender, age, height, attitudes about anything, personality, any of these things can be a variable. When we talk about variables, we'll often talk about independent and dependent variables. So independent variables have at least two levels, and typically we either manipulate or observe these variables to determine their effect on a dependent variable. So we like to think of our dependent variable as the outcome variable, and we think it's somehow related to or caused by changes in the independent variable. So for example, here, does gender predict one's attitude about politics? So in this case, gender would be our independent variable because it's something that we're observing. In this case, we won't manipulate it. That might be unethical. And we're interested in this outcome variable of your attitude about politics. So once we've defined our independent and dependent variables, we want to take some time to think about how we're measuring these variables. So there's four main measurement scales that we can talk about, and there's a couple of examples of each. So a nominal scale is really just a label or a name. So something like religion, ethnicity, gender, it's just a way of labeling or categorizing something. So we're not really saying that one group is better than another, we're just giving them a label. So the next level of measurement scale is the ordinal scale. In this case, we're adding this idea of magnitude or a rank order to it. So if you think of something like class rank, we know that the person who's number 1 is ahead of the person who's number 2. We don't necessarily know by how much though. It might be the difference of a 4.0 GPA to a 3.9, or maybe the number 2 person has a 2.0. We're not really sure of the distance between the ranks. We just know that one person is higher than another. The next two I kind of like to lump together, the interval and the ratio scale. In this case, it's like an ordinal in which we have magnitude or rank, but in this case, we have equal distances. We know about the spaces between the values, and in the case of a ratio scale, there's an absolute 0. The type of measurement scale that we use when we're doing research is really important because it really drives the type of statistical tests we'll be able to run. As a general rule, and we'll see this as the semester progresses, the interval ratio scales, we tend to have better information and we're able to run more powerful statistics with those kind of measurements. So if you think of something like temperature, I could say that it's cold versus warm in different states. Maybe Nebraska's cold, Iowa's only kind of cold. So those would be nominals or categories, right? You get the idea that they're different, but it's not giving us a ton of information. On the other hand, we could use an ordinal scale and we could say that Nebraska has the 3rd coldest winters out of all the states. So we would have a rank order with more information, but you can see it's still really not great information to have. It would be much preferable to use an interval scale and say the average temperature of Nebraska in the winter is 31 degrees. Hopefully that's not the case. But you can see how as we move up in those measurement scales, we have more precise data, and it's giving us a lot more information than just those nominal or ordinal scales. This idea of measurement scale will be really important as we progress and talk more about statistics. So for now, those are kind of the basic vocabulary language that we wanted to talk about. This idea of variables, whether they're independent or dependent, how they're measured, and the idea of a sample versus a population. So that'll kind of set the tone, and in the next video, we'll get into a couple of descriptive statistics, specifically talking about measures of central tendency and variability.